Today's problem is 2501, longest square streak in an array. You're given an integer nums. A subsequence of nums is called a square streak if the length of the subsequence is at least 2, and after sorting the subsequence, each element except the first element is the square of the previous number. I think it needs some water. Is a square streak if the length of the subsequence is at least 2, and after sorting the sequence, each element except the first element is the square of the previous number. Return the longest square streak in nums, or return 1 if there is no square streak. Okay, so the brute force solution would be pretty straightforward. You could just have a helper function that checks that the next value in the array is the square of the current element. And then you would go through really just every subsequence, sort it, and then check if it's a square streak. But what's the problem with this? The problem is that it costs a lot to go through every permutation. For every permutation, be sorting it, and then you go through every single subsequence. For every subsequence, you'd be sorting it, and for every time you sort it, you'd then be going through each element again. So it'd be like O(n) to the third log n, something like that, which is way too much. So what do we do? One thought, because we need a way of recognizing squares. Oh, and subsequence. Oh, wait, so we can, sorry, we can take any, they don't have to be, I got that wrong. It doesn't have to be a sliding window because you can just take any combination of elements. I always mix up, you know what it is? I always mix up sub, or like sub array and subsequence. Because we're sorting it anyway, so it doesn't matter if we retain the order. So as long as we can skip elements, we can get any group. This is funny. It says a subsequence is an array that can be derived from another array by deleting some elements or no elements without changing the order of the remaining elements. But we're sorting the subsequence, so we are changing the order. So I say to hell with this idea um, of retaining its order. Let's right off the bat, I'm thinking that we sort the array. Let's see, where are the topics here? Yeah. Okay, sort the array. From this point, we should be able to basically build up subsequences. How about this? Sort the array, and then we have a 2D array of subsequences, of square streaks. All right. And then for every element, because in order for it to be a square streak, it has to be the square of the last element in the square streak. So for every element, check if there's a square streak for which the last square, the last number squared is the element. If so, add to that array. If not, start it as its own square streak. I think that's pretty good. Why don't we try that? I don't think that'll be that long. Let's just try that. Okay, so nums sort, I don't care. Now we could just say square streaks equals a 2D array. And we'll say for num in nums, and we'll say for square streak, we'll say, well, how about we have a Boolean that says added num. We'll set that to be false, and then at the end, if we don't add it to any, then it's still false, and we will add our own square streak. For square streak in square streaks, if square streak at the last digit equals at the last digit squared equals num, then we'll say square streak append num. And then we'll, because it can't happen with any other square streak, because otherwise it would be a part of this, we'll say added num equals true, and we'll say break to get out of this the thing. And then for this number, we'll say if not added num, then we'll say square streaks. I think we might need to change this to an index loop, but we'll see. Square streaks dot append a new array starting with the number. All right. Now we can just say return. We'll say max streak equals, we can say max streak length equals say max in square streaks key equals length or length. And then if max streak length equals 1, return -1. Otherwise, return max streak length. That'd be crazy if that worked first try. Does it work for large inputs? Probably not. Okay. So how about, if that's too long, how about this? because we're the problem is, I believe, we're iterating through square streaks every time. What if instead we did that thing? You know how we did two sum? And two sum, we have like the key is the complement. So really the key that we're looking for. So we're looking for two numbers that add to a certain number. So when we go through, we say key. When we go through the array, we say, okay, well, we're looking for a number 5. So we find a 2, which means we're looking for a 3. So what if we do something like that? We're actually looking for a complement. And then this would make use of the hash map. Oh, okay. And then we don't actually even need to keep track of the streaks up to this point. So I'm thinking we have a map where the key is the value, is the square value we're looking for. The value is the length of the streak so far. Yeah. How about that? Let's try that. Okay, I'm gonna delete all this. I still like it being sorted, but now we're just gonna change this to be. We're gonna delete all that. Okay. So we're gonna say active. We'll say square streaks equals. Do we want this to be a default dictionary? No, because we could. Why don't I just say like a default dictionary? I mean, part of it is going to be that's not in there. I don't know. Let's use a default dictionary. We'll set it to be -1. Okay. So now we're going to say for num in nums, we're going to say, I guess this can just be a regular dictionary. For num in nums, we're going to say if num in square streaks, then we're going to say square streaks num. Oh, this is so it. Square streaks num squared. We'll say next val equals num squared. Square streaks next val equals square streaks num plus 1. Okay, and if it's not in there, then we're going to say, oh, wait. No, we could just do a default dictionary. And it'll just be 0. That's it. So that's the length of it so far. That's so it. And then we don't even need to check if it's in there. So here's what I mean. So we have a default dictionary. A default dictionary means that if you try to access a key that's not in there, you get the default value of 0. So I'm saying for every number in nums, and nums is sorted, so if we get a number, so we're not going to go out of order. So we're not going to get 8 and then later on we get, so we're not going to get 4, and then later on we get 2. We get 2, which means that when we get 4, we can check to see if we already have 2. So we say the next value in the array is, so the next value that we're looking for is the number squared. And then so we set that dictionary. Yeah. Awesome. And then actually, so the max length will be -1 because the dictionary will contain, will be -1 because the dictionary contains all the numbers that you haven't found yet but are looking for. So basically what I'm saying is that, okay, so you find a 2 and you say, well, 2 squared is 4. So now if we see a 4, then give that 4 the value of 1 and then square that. So now 4 is looking for 16. So we say, okay, if we see a 16, give that a value of 2. And then we can just get the max of the items. So return longest equals max of square streaks dot items. No, vals. Values? -1. If longest let's see, equals 0, then return -1, otherwise return longest. Does that work? I've never seen that before. Okay, so int. There we go. Oh, that's slow. That's surprising. I guess it's a pretty quick algorithm. Would it be faster if we didn't use that? What if we, instead of just, what if we just keep track of longest and longest equals 0? I'll say longest equals max longest. And then at the end, we don't even need to go through it again. Does that work? Oh, wrong answer. Does that work? Oh, it's still slow. What do people do that was fast? Yeah, the same thing. Oh, well, I guess they do it with square rooting. I don't know. I don't see why mine's any slower than anyone else. Um, I'll take it.